In this scenario, we are looking at an aircraft hangar protected per the Unified Facilities Code. The Unified Facilities Code is a directive put out by the U.S. Department of Defense on the methods used to build their facilities. The hangar is protected with an electric release pilot pressure regulating flow control system. A pilot pressure regulating flow control system is used to control the pressure of the discharge devices and can be shut off remotely and quickly. The system utilizes a J1 flow control valve and standard flow control trim with the addition of a C2 pilot pressure regulating valve and a speed control valve. The J1 flow control valve can be remotely reset and its priming chamber can be regulated. With enough water pressure in the priming chamber, in conjunction with the spring strength within the flow control valve, the clapper can be forced downward against the seat, automatically shutting off water flow to the system piping. The speed control valve controls the flow of priming water in and out of the priming chamber. The back pressure is sensed on the outlet of the C2 pilot pressure regulating valve, and then the speed control valve is there to control the flow of water in and out of the prime line. The proportioning method required by the Unified Facilities Code is an inductor. The inductor draws foam concentrate from an atmospheric storage tank. The inductor is a strong venturi device. Water velocity through the device creates a vacuum on the foam inlet of the device, drawing foam concentrate into the water stream. The Unified Facilities Code requires that foam water stop stations be supplied throughout the hangar, so inadvertent operation of the system can be immediately resolved. The foam water stop station is set up as a dead man switch, meaning the system operation will be interrupted while the button is pushed. Once the button is released, the system will reactivate unless the system has been reset. The detection devices used are triple infrared detectors in a cross-zone configuration. In a scenario where a fire has started in the hangar and begins to grow, the electronic detection devices activate and send a signal to a release control panel. The electric solenoid valve is powered open, releasing water pressure within the priming chamber of the flow control valve. The flow control valve's clapper opens. The priming water exiting the priming chamber passes through the adjusted speed control valve to the inlet of the C2 pressure regulating valve. The water flow alarm is activated. As water discharges from the flow control valve, discharge water will be present at the outlet of the C2 pilot pressure regulating valve. The regulating valve controls the position of the clapper in the priming chamber by controlling the flow of priming water exiting the priming chamber. Water flows through the riser to the inductor. Water passing through the inductor creates a vacuum at the foam inlet side of the inductor, which pulls foam concentrate into the water stream. Foam solution is created with a mixture of foam concentrate and water. Foam solution is supplied to the high expansion foam generators. In the event of a false system activation, the foam water stop station is initiated, interrupting the power to the normally closed solenoid valve, which stops priming water from exiting the valve, whereupon the flow control valve closes immediately. Once the button is released, the system will reactivate unless the system has been reset.